All right, the f is just a function. If it is differentiable function, then f prime of c is no condition, exists, no condition, always exist. But again, this local extremum, this condition in here is concerned with that type of situation. Right? Does it look like this is local maximum? Locally, that's the highest point, but the derivative doesn't exist. Therefore, f prime of c is not 0. So if you're staring at the local maximum, either it's f prime of c 0 or it doesn't exist. So it completes this logical conclusion. Okay? So this has a neat proof. Okay? So this proof. This is a commonly accepted structure of a proof these days. But back then, people didn't like it. What's given here is that f of c is a local extremum. That part is given, correct? And f prime of c exists. This is also given. So I don't think we have to put that in there. F prime of c, we want to conclude f prime of c is 0. Suppose it's not 0. Okay? Say it's positive. I'm going to call m positive. What if it's negative and you repeat the same argument I'm about to do exactly with it negative, but there's not much different. It's just little doodling, and that's it. Right? So here it's let f of c m times x minus c. Who remembers this thing? What is this? F of x is nothing is known. We don't know anything about f of x. Then I'm writing f of x is actually equal to f of c plus m times x plus c plus something. Does anybody remember what this is about? This type of there's a name for this first two term. Point slope formula. Good start. What's the fancy name for this point slope formula? L of x. What was the name for that L of x? Linear approximation, right? Doesn't matter what the f of x is. You don't have to know what f of x is. You can still write down linear approximation like this, right? And what was the error term? This is exactly equal. It's not approximation. So error term looks like this x minus c times ex, right? And what do we know about ex? Approaches 0 as x approaches c in there, right? Is that correct? So I'm going to write it like this. F of c is out there, and x minus c and m plus ex if you factor out x minus c there. So as I'm going to do two things. As x approaches c from the right, is f of c plus, isn't that a positive factor there, x minus c? Is that right? If x is approaching c from the right, slightly greater than c, so x minus c is a positive, right? M is a positive number, right? Doesn't matter how small it is, it's a positive number. And what is happening to e in there? E is approaching 0. So would you believe that as you approach c, this m is a positive number plus almost 0? Isn't that approaching almost m? Right? That's the limit laws, right? So altogether it's approaching 0, but it remains positive. Is that right? Because m is a positive. So this is a slightly greater than f of c. Correct? f of c is there, and you're adding positive plus times a positive m, correct? So altogether it's a positive number. Although it's approaching f of c, but it's slightly greater than f of c, correct? So does that mean that f of c is not going to be a local maximum? Because right next to it, as x approaches c from the right, there's always this function value, f of x, is greater than f of c, right? So from that, what is the conclusion? F of c is not a local maximum, because I found greater value than f of c. Right next to it, to the right, there is a function value, f of x, that is greater than f of c, correct? It's not a local maximum. As x approaches c from the left, we have the similar conclusion. F of x is f of c plus what is x minus c is a negative number, right? But what about m? M is still there, m. So it is close to f of c, but it is slightly smaller. So this is slightly smaller f of c. If you look to the left, approaching from c from the left, then the function value f of x is smaller than f of c. So from there, you can conclude what? F of c is not local minimum, because right next to it, there's a smaller value. Right? So if f prime of c is a positive, we conclude f of c is not a altogether local extremum. Right? But we said that at the beginning, it is a local extremum. What are you talking about? It's given. But if you suppose f prime of c is not equal to 0, then you end up at contradicting the property you were given. So correct conclusion is that this possibility, f prime of c being non-zero, never happens, because it contradicts itself, the condition we have it in there. So let me write it this way and let you go. Not local. Contradiction to the property given, which is the local extreme property. Sorry. Local extreme property. So that of our supposition f prime of c being a non-zero number never happens. Well, I said positive. I assume it's a positive, right? So I should write it like this. If you assume it's a positive number, this never happens. What if it's a negative number? You go through the same argument, and it never happens. So positive, negative is not the possibility. What's left is a 0. Therefore, you conclude it's 0. Okay? That's a proof. And this is in the very important part of a chain of reasoning for what is coming next. So that's why I'm considering it's readily available for, with linear approximation. Sorry for holding too long.